Physics 2 Light and Optics YouTube channel. My name is Abhi, and today we're going to be going over some of the basics of visual and digital effects and outlining how motion capture works in regards to optics. So to start the video, I want to explain what visual effects are and why they are used in films. And essentially, visual effects is the process by which the imagery in a scene is changed or created outside of the actual filming of the shot. So for example, in this Avengers photo here on the left, the skyscrapers that are in the final shot or final version of the film were actually added outside of the filming of the scene, so in post-production. So you can see the green screen here was actually replaced by skyscrapers after the fact, and Mark Ruffalo's mocap suit and this technology, which we'll get into later, was again transformed to the Hulk. You can see this also in the next two photos here, where the background was a green screen and was replaced by realistic looking environments. And so the reason, again, why visual effects are used in films is to create environments and characters that look realistic, but to actually create in real life would be dangerous, expensive, impractical, and even impossible. And so basically visual effects bring the impossible to life on screen. And so nowadays, VFX is split into two different categories. That is digital and special effects. And for most of this video, I'll be focusing on digital effects, but I wanted to begin by outlining the difference between the two. So digital effects essentially combines still photography or computer-generated imagery, also known as CGI, to a real-life scene or movie, whereas special effects are visual tricks or illusions used during filming of a scene to add effect into it. And basically, a subset of digital effects that I wanted to focus on in this video is motion capture. And so motion capture is the process of recording the movements of objects and or people. And so essentially how this works is that the subject is recorded and sampled several times per second by different scanners placed all over the environment. So you can see here in this picture on the right, we have NBA player D'Angelo Russell, who is in a mocap suit so that 2K games can record his movement for NBA 2K to nail his animations in the video game. So mocap can be used in film and video games, so that was just one example. Another thing I want to focus on with motion capture is facial motion capture. So to create fully CGI characters, mocap technology or motion capture technology will be used to record facial movements and expressions of people's faces. So for example, here we have Andy Serkis playing Caesar in Planet of the Apes, Zoe Saldana in Avatar, and Christian Bale playing Bagheera in The Jungle Book. And so all of these people had to use facial motion capture to show their emotions while acting. And in comparison to body motion capture, facial motion capture actually requires higher resolution to detect and track all the minute details and subtle expressions of the human face. And all the data points collected from the markers on the actors' faces from the facial motion capture basically render a 3D model and essentially creates a rough model of all the animations required for the character. And the thing is that facial motion capture is a very intricate and difficult thing to master because the way the skin moves and the way that certain parts of the face move in regards to your body and just in general is very complex, and so it's something that I wanted to point out within motion capture. So now we're going to get into the more technical side where we're going to talk about how motion capture works in regards to optics. So essentially there are two main technologies used for motion capture. That is passive markers and pulsed LED markers. Passive markers are generally more used for facial motion capture. That's why I had it in the title. But pulsed LED systems measure the infrared light emitted by the LEDs, and then passive markers essentially measure the light reflected from the markers. And so all this data is used to capture these points in a 3D space. And how that works is that the centers of the markers cover a known object or person at different known positions, and this data is used to calibrate the cameras and obtain their positions. And so this process is also called triangulation, where each position frame to frame is computed in 3D space to create an accurate 3D model. And so this is essentially just how motion capture works in regards to optics, and a lot of it is light and reflection and refraction. So kind of basic concepts, but rendering it into the computer and creating this model is, again, very deep and complex. So thank you for watching this video on visual effects and motion capture in film, and specifically how optical systems work to bring the impossible to life on screen. Again, thanks for watching, and subscribe to the Physics 2 Light and Optics YouTube channel.